So for projectile motion on the first example, a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. This is the equation that will mimic what's happening with the soccer ball. It gives the height h of the ball after t seconds. So think and look about what you've got here. You've got h, which is your height in feet. You've got t, which is your time in seconds. Then you've got h of t, which is your height at a given time in feet per second. Okay, so on the ground, okay, you're standing here and you're going to kick the soccer ball and it's going to rise to a maximum height and then it's going to start coming down and it'll hit the ground again. So this is going to restrict our domain away from all real numbers. So with the given function, you have h of t equals negative 16t squared plus 90t. The very first part of the question asks us how many seconds will it take for the ball to reach its maximum height. The maximum height has got to be your vertex point. In a parabola, your vertex point is first found by using the formula x is equal to negative b over 2a. So in this equation, negative b will be the opposite of 90, which is negative 90 over 2 times a, or 2 times negative 16. Having a fraction for your answer, since we're looking for x, which is time, is going to be ineffective. So take negative 90 and divide it by negative 32, and you'll get 2 and 8,125 ten-thousandths. And since this is our time we're looking for here, it'll be in seconds. So 2a is 2.8125 seconds. Okay, so remember the vertex point is usually x and y, but in this instance it's going to be t and h. So we'll have t as our time in seconds and h is our height of the soccer ball. Okay, and so when we plugged into negative b over 2a, we found our x value, which was our time. If you want to know the height of the ball at this time, then you'll have to plug in and find your y value, which is going to be the second part of the problem. What is the maximum height of the ball? So remember, what goes up must come down. So once it reaches its maximum height, it's going to curve and come back down to the ground. So in order to find out what your height is here, you're going to plug in, wherever you see t, the time that you found for your x and your vertex point. So plug this in. Okay, so we'll have negative 16 times our time squared plus 90 times our time. Okay, and so this is going to be the maximum height. Now the maximum height is measured in feet. Okay, so let's put that down for B. Okay, so remember, when you are dealing with projectile motion, your vertex point is going to be your maximum height and your maximum time, whatever the case, if you're talking about time and height. And if it's going the other way, it'll be your minimum. Okay, but if you're going to be launching something, it's usually going to be an upside down parabola. Now on part C, it says to give the domain and the range of the function. So think about what we did here. Your domain is going to be restricted from when you kick the ball to when it lands. Okay, so these are going to be the zeros of the function because these are your ground situations. So what you want to do is you want to take and you want to factor out h of t equals and solve it for 0. So replace h of t with 0. Then we're going to factor out a GCF of negative 2t. And then set both of these equal to 0 and solve for t. Okay, add 45 here and divide both sides by 8. Normally we'd leave this 45/8, but since we're looking for time, take your 45 and divide it by 8 and get a decimal equivalent. Okay, so where our domain is normally all real numbers for a parabola, we're starting at 0 and ending here. And both of these are in time, seconds, okay? So this is going to be my domain restriction. We're going to go from 0 to 5 and 625 thousandths of a second. Okay, and that is also going to affect the range. So if you think about it, when t equals 0, your height equals 0, okay? And then you're going to steadily climb, hit the maximum, and start coming back down. And when t is equal to 5 and 625 thousandths of a second, your height is also at 0. So at both of these times, your height is at 0. So what is the restriction going to be for our range? Okay, so 0 is going to be the least value that we're going to deal with for our range. Now, this is going to be the highest value that we're going to deal with for our range. So the highest value is going to come from that vertex point. So our vertex point value that we have right here is 2.8125 and 126 and 5,625 10,000ths. So this is my highest value for y. So I know that y will be less than or equal to this number right here, because this is the highest point and it's going to go straight down. And then it's going to hit right here and it's not going to go any lower. So it's going to bound between 0 and that 125 point. And this, of course, is in feet. Okay, so we're not used to, once again, having a restricted domain, but because you're going to start at one point and end at one point, that's going to restrict the domain. You're used to your range being restricted. However, this time it's going to be restricted on both ends. Okay. All right, so when you get to number 2, an apple is launched directly upward at 64 feet per second from a platform 80 feet high. The equation for this apple's height, h, at time t seconds after launch is, so here's our equation. We want to know the height of the apple after 3 seconds. Well, remember, seconds is our time, which is t. So what we need to do is go to our equation, and wherever we see a t, we'll replace it with 3. And then we'll plug in all of these values, and we'll see what we get. Negative 16 times 3 squared, which we know to be 9, plus 64 times 3, plus 80. That'll give us 128. So after 3 seconds, our apple has reached a height of 128 feet. Now, number 3, a toy rocket is launched vertically upward from a 12-foot platform with an initial velocity of 128 feet per second. Its height at time t seconds after launch is given by the equation. How long will it take the rocket to reach the ground? Okay, so we're going to the ground, which will be 0. And so looking at our equation here, once again, if we're looking for when it hits the ground, we're going to be at h of t equals 0. Looking at this and trying to factor it would take quite some time. So what we're going to do instead is just plug this into the quadratic formula. So we'll have x is equal to negative b, which will be negative 128, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, or 2 times negative 16. Because we are looking for a time, leaving this in radical form would not be acceptable, so let's just go ahead and plug it into our graphing calculator and get our answer. So we'll have negative 128 plus the square root of 128 squared minus 4 times negative 16 times 12, all over negative 32. Okay, so that's going to give us negative 0.09. Now if we go up here and highlight this and change this instead from a plus to a minus, make sure you use the minus sign. That's going to give us 8.09. okay? So it's asking us for a time, t for time. You're not going to have a negative time value, so that tells me that x is going to be 8 9/100ths. Since we are talking about time and it's measured in seconds, it'll be 8 9/100ths seconds. And on number 4, a penny is dropped off the Empire State Building, which is 1,250 feet tall. If the penny's pathway can be modeled by the equation, how long will it take the penny to strike a 6-foot tall person? Okay, now when we were solving problem number 3, the toy rocket was launched and then it hit the ground. When it hits the ground, h of t is equal to 0. This time it's not going to hit the ground, it's going to strike a 6-foot tall person. So instead of h of t equaling 0, this time h of t is going to equal 6. Okay, and so to solve, since we just have a t squared and a constant, I'm going to use square roots to solve this. So I'll subtract 1,250 from both sides. And then divide both sides by negative 16. Now take the square root of both sides. So if you go to your calculator and do second square root with 77 7/75, we'll get this long decimal. Let's go out 2 decimal places. We'll get 8 82/100ths. Normally, we would do the positive and the negative value here, but since we're talking about time, we only need the positive value. So 8 82/100ths